Today, we are talking about the need for a common ground in circuitry. Let's dive in. Imagine the situation where I have an Arduino and I want to power and control a servo. Now, I know that I need to control that servo with that green wire that is connected to the PWM pin 9 of the Arduino into the signal pin of the servo. But sometimes I don't want to provide the power source to that servo from the Arduino, as it might not be able to provide the current needed, as the Arduino can only put out a limited amount of current. In which case, I might want to power it from an external power source. To do that, I'm going to use a breadboard and I'm going to use the power rails of that breadboard, and I'm going to plug the positive end of an external power source into the positive of the servo and the negative end into the negative of the servo. In this case, my external power source is represented by a potato. Of course, a potato cannot provide 5 volts at a higher current than Arduino can, but humor me for a second here. So, if I were to do this though, I would need to connect the ground pin of my Arduino to the negative terminal of the servo and external power source. Let's have a look at why that is. I'm going to use the analogy of a person holding a ball and dropping it as the analogy for a voltage being dropped over a load producing a different kind of energy, such as light if it were a light globe, such as kinetic energy if it were a servo or another type of motor. Let's look at the energy of this ball at the current situation. Let's say that it is 1.5 meters above the ground, and hence all of the energy of that ball is in its gravitational potential, which is its mass times gravity times 1.5 meters, as it is 1.5 meters above the ground. As I drop that, that potential energy is converted into a usable type of energy potentially, which in this case would be kinetic. And in that moment, just before it hits the ground, well, then I have the amount of kinetic energy produced was the potential energy being transformed into kinetic, which is mass times gravity times change in h, which in this case is of course 1.5 just before it hits the ground. So you see that I have potential energy transformed into something usable, just like in a circuit. Now imagine that this person is instead on a ledge above the ground. Let's say the ball is still 1.5 meters above the ground that they're on, but that ground is 10 meters above some other ground level. I can choose my zero gravitational potential level as my zero datum line that defines where my ground is, and I can do the same calculations. The initial amount of energy of the ball is still just gravitational potential, which is the same as before. And as I drop that, that potential energy is transformed into kinetic energy that is just the same as its initial energy. Let's now add a person on that ground level that's 10 meters below the top one. I can now actually change my level, my datum line, my zero potential energy level to be that bottom ground level and do the maths again. The initial energy of that top ball is just going to be all gravitational still, but in this case it is 11.5 meters above the ground. But as I drop it and just before it hits the ground, the final energy now, it still has gravitational potential, but it also has the kinetic energy that was transformed. And of course, the kinetic energy that was transformed is still the exact same. I just still have that gravitational potential energy component as well. But if I look at the bottom scenario, instead, that is 1.5 meters above the ground. The initial energy is, of course, identical to the original initial energy. And after dropping that ball, well, the amount that was transformed into kinetic is still just the amount that it was originally. So based on this, you can probably see that different scenarios can be at different levels or different altitudes, but it doesn't actually matter what starting level they're at. It matters how much of the potential energy is used up and transformed into a different kind of energy. You can see that this is analogous to the voltage because it may not matter where we start our voltage from, it matters how much of that potential energy is transformed into something else. So let's compare that to our circuit here, where I have an Arduino that is able to provide a 5-volt difference between its 5-volt pin and its ground pin, and I also have an external voltage source that can do the same. But if I were to call the ground pin of the Arduino 0 volts, that doesn't mean that the negative terminal of the external power source is at that level. It might mean that it is at 10 volts and 15 volts as its positive and negative respectively. Now, of course, this is going to create problems. If I relate it to this scenario here, where I have my Arduino 5 volts and Arduino ground as my bottom level person, and my potato 5 volts and ground as my top level person, and when my servo is using that top level 5 volts and ground, here, I'm expecting to see a PWM signal that looks something like that. But instead, I'm getting a PWM signal that is down there. And of course, there is a 10-volt difference between what I want and what I'm getting, which of course is going to be interpreted by the servo as something that is not what we're wanting, and it's not going to behave in the way that we're wanting it. So therefore, what I need to do is create this ground connection such that I link the ground pin of my Arduino to the negative terminal of my external source, and then I can force that external negative terminal to be at 0 and 5. And what that does is it brings the negative terminal of that external power source down to match the ground pin of the Arduino. Now, when I give my signal, it is at the voltage level that I required. So you see that voltage is all about a difference, which is why we call it a potential difference. Two components might have 5 volts written on them, but that doesn't mean that they are at the same voltage level. It just means that the difference between the negative and positive terminals is at the stated voltage level. So don't get confused when something says 12 volts on it. That doesn't mean that it is a universal 12 volts. It just means 12 volts between its two terminals.